As soon as you have all of the members drawn, you can begin testing your bridge. These two buttons up at the top are going to be really useful. The load test lets you actually drive a truck across it and see how strong it is. And then the drawing board lets you go back and work on it. So if I take this to the load test, we can see the bridge is starting to get bright red. That means it's getting close to failing. And we see that it failed in the middle. So to go back to the load test, it actually shows you which pieces broke. Now this is going to be really useful because as you're designing your bridge in SketchUp, you now have an idea of which pieces need to be stronger. But just as important, we also now have an idea of which pieces don't need to be as strong, and we can reduce those pieces so that our bridge has a higher structural efficiency. The easiest way to go through this process is to select the pieces that broke, and you can select more than one by holding down the control button. So I want to fix those 4 pieces, and I just make them 2 sizes larger. And let's go ahead and test it again and make sure we can get it to at least get the truck across. There we go. So now we know our bridge can support the truck. And you can kind of get an idea right away of which pieces we're going to be able to reduce the size on. Some of these V pieces in the middle are barely getting blue or red. The darker the color, the closer they are to failing. So we're getting pretty bright red on the top and kind of dark blue on the bottom. But once I get the bridge working, I'll just select the entire bridge and decrease the entire bridge by 1 click. Then I test it again, and I watch to see if anything fails. And we've got a piece fail. So now I go back, and I'm going to take those 3 pieces that failed and increase them 2 clicks. Then I'm going to select the entire bridge and reduce it by 1. So by going through this process over and over, you're going to continue to strengthen the pieces that are breaking, but reduce the pieces that are not breaking. And eventually you should end up with a bridge that has a really high structural efficiency. You're not wasting material on pieces that don't need to be strong, but the pieces that do need to be strong, you set them to just the right size that they can carry their load. So we'll do this one more time and test it. And go back to the load test, and now we can again see which pieces broke. And I'll increase those by 2. Alright, so we'll pretend I had gone through this process multiple times, and I've really maxed it out to have almost every piece just on the edge of breaking, but not breaking. Then you're going to go to the member list, and you can see every one of your pieces. They're numbered over here on the side. You can click on them and you can see what part of the bridge they are. And if you click on it, you can actually sort it by size. And what this does is it shows me now, when I go to design this bridge in SketchUp, which pieces need to be stronger. And if I click on one and hold Shift, I can see over here in the bridge these 4 pieces. They all had a size of 160. And then these 4 pieces all had a size of 140. The rest of them were all the same. So in SketchUp I could draw a bridge and just have the width of the pieces all be the same, except these pieces and these pieces I could design with a thicker width or a thicker dimension so that they are stronger and can help carry the load without breaking. So that's kind of a basic overview of how you're going to use West Point Bridge Design to kind of virtually test your bridge and create a template that you can then bring into SketchUp.